Saxon's Calculus Lesson 22 is about interval notation, products of linear factors, tangents, and increasing and decreasing functions. So in part A, the interval notation, mathematicians were looking for a way to abbreviate writing out set notation things where we would say something like x is an element of the reals such that x is greater than or equal to 1, because that takes a while to write and say as well. So they created a shortcut version of this, which would say something like if they will use a parenthesis if the number that they're attaching here is not equal to, make sure I'm not saying that backwards. Yes, is not equal to, and they will use a brace this way if they are saying the number that's written closer to it is included. So since this has an equal 1, you would be using 1 with this notation. Now let me get a little more specific. So if they would give you -3 is less than x, which also has to be less than 2, what you're going to say is, I'm not touching either one because there's no equal. So we're going to use a parenthesis, and we're going to fill in -3, 2. Now the only problem with this is when they're both in parentheses and not equal to, this looks to me like a coordinate point as opposed to providing me boundary information. You almost just have to go with in what context is it given to you to know when it's a coordinate point and when it's not. So if we said we were given -3 is less than or equal to x, which is less than or equal to 2, then we're using or equal to, so we have the brace with both and then the -3, 2. Now that one I'm not going to confuse with a coordinate point because I'm using a brace bracket symbol for both. You can also have a combination. If you have -3 is less than x, which is less than or equal to 2, you're going to parenthesis the non-equal to, and you're going to brace the equal to 2. And there's one other thing to give you besides just the numbers, and that is what happens when we're dealing with infinity. Should be a little more on its side, but positive infinity would be implying that I'm dealing with like 2, positive infinity, 2, 3, 4, 5, 6, forever upward. And depending if I said it's or equal to 2, then I will use the bracket. But always with infinity, you can't actually touch it. So anytime you're using the infinity or negative infinity, oh, good grief, that's even worse. There we go. Negative infinity, you're going to always use the parenthesis with that because you can never touch infinity. Now that we have discussed all of that, look at example 1. Designate the following intervals by using interval notation. Okay, so they give us 4 is less than x, which is less than or equal to 30. They give us x is greater than or equal to 22, and they give us x is less than -42. So this one, we don't have the or equal to, so we know it's a parenthesis with the 4, 30. This one has the or equal to, so there's our interval notation. Now this one is starting at 22 and going greater than it for forever. So 22 is the lower number, bracket because of the or equal sign, and we're saying up to, since it didn't give me another limit, this is an infinity one and with a parenthesis. And then the last one is less than -42. So that's my negatives going this way. So negative infinity is going to be listed first with a parenthesis, then the -42, and it's not or equal to, so it has to have another parenthesis. So the only time, and again, this I'm not going to get confused with the coordinate point because of the infinity symbol. The only time it's a problem or potentially a problem is if it's that way. Example 2, page 122. On which interval is this function positive? I'm going to pause it long enough to graph this. All right, so now that I have my graph here, the question is asking on which intervals is this function positive? So here is my 0. The line just happens to be going through it. And the numbers below it are, of course, negatives. The numbers above it are positives. And so when it's asking where it is positive, we're talking about from this dot and this direction, it's positive. So this is actually the negative infinities coming up to hit the -8. So from negative infinity, which I know will be a circle, to the -8. Now the question is, what happens at -8? Is it positive or is it 0? It's hitting the x-axis at 0, so it's 0. So it's not actually equaling -8 because that changes it from being positive to being 0. Now, is it here? No, these numbers answers are down into the negative, so not there. From -4 to +4, I have all answers in the positive section. So from -4 to 4, oh, I instinctively put the parentheses. But again, these are 0 answers, so they're not included. And then these are negatives, so I won't use that list. And then from 8 and above, I am positive again. So from 8 not included through infinity, again, which I can't include. And I do apologize. It's hard to write that 8 sideways, but it should be completely sideways. Now, part B switches to products of linear factors. So what they're doing here is they're saying, if I have this graph, let's say, obviously I have things below 8, things below -8 and -4, things between -4 and 4, 4 and 8, 8 to infinity. So if I plugged in numbers or used this graph, like if I didn't have the graph, if I just had these numbers with the dots, what would I say is happening in this section? They're positive. What would I say is happening in this section? They're negative. In this section, they're positive. In this one, they're negative. And in this one, they're positive. So that's what they're doing here in this product of linear factors. They're saying if you have a whole list of things like, so for this example, it would be something like x plus 8, x plus 4, x minus 4. Notice that as I'm multiplying all of these together, I'm changing the sign because I'm putting them into the parenthesis, and then it would also be multiplying with an x minus 8. So if you were multiplying all of these things together as the function, this is what you would graph, these sections. And so you're assigning the positives and negatives depending on what their answers are spitting out. Now, I will tell you that most of the time the symbols will alternate, but not always. So you can't guarantee that. You really do need to test each and every one to see what is happening. So when I am given something like example 3, where it says, A, use a number line, and B, interval notation to show the intervals on which the provided function is positive and when the function is negative. So they're giving me f of x equals x, x plus 3, x plus 6, x plus 2, and x minus 5. Just a second, I think that's a minus 2, and I wrote it as a plus. Let me triple check the rest. X, x plus 3, x plus 6, x minus 2. Yep, okay, now I'm back on track. So in part A, it definitely wants me to sketch it on a number line and figure out what's going on. So on my number line, let me put 0 about in the middle. This x would have to equal 0 if this whole function were set equal to 0. Then one of my dots would be here. This dot would be at -3. This dot would be at -6. This dot would be at +2. Oops, try to space them evenly. And then +5. 3, 4, 5. Okay. So here are our sections. And so ultimately, we're kind of looking at creating, not really asymptotes here, but just section dividers. I'm using the dash just to kind of show the dividers. And then I do need to continue this way, and I had a little bit there, I could see it. So I need to plug in numbers in each of these sections to see whether the answer in these sections is positive or negative. Now the book does it a little bit differently. They choose to plug in a 1 and pull their positives and negatives from that, and I find trying to figure out whether I'm getting above or below the -3 just becomes confusing to me. So I would rather mentally or on my calculator quickly just test all of these series of numbers. So for this section, I would test a 6 because it's above the 5. 6, positive, 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 still positive, still positive. So I know for sure all answers coming out of that because multiplying all positives is positive. All right, I would do the same thing in here. And I'd probably test my smaller number 3 just because I'm trying to hold them in my head. So 3 is a positive, that's a positive, that's a positive. 3 minus 2 is still a positive. 3 minus 5, however, is a negative. So one negative would override all those positives. So I am doing the alternating pattern. So I assume it's going to be positive, negative, positive, negative. But I want to check them still just to be sure. So 1 is positive, that's positive, that's positive. 1 minus 2 is negative, but 1 minus 5 is also negative. 2 negatives make a positive. Overall, I'm good. Now let's test -1. Well, that's negative. That's positive. That's positive. That's a negative. That's a negative. That's 3 negatives. So overall, that would make it a negative. And then here I would test -4. So that's negative, negative, positive, negative, negative. 4 negatives is going to overall make a positive. So you're getting the idea. And then I would test the -7 and see that it gives me a negative and so forth. So now that I have them definitely clarified, A, in my number line, B wants it in interval notation to say which ones are positive and which ones are negative. So I would say that positive answers are occurring at -6 to -3, and we're not touching those because they're zeros. Also positives at 0 and 2, and 5 to infinity, and then negatives at -infinity to, I'm getting better, -6, and -3 to 0, and 2 to 5. Those would be, just double checking my answers, that would be the positives and negatives for part B. Section C is about tangents. Now tangents, if you recall, like when we had a circle and we had its tangent, it was a line crossing it in one spot. Well, that's the same thing that we're doing here, except that we're going to be finding the tangents not to a circle, but to a curve of some sort. So anywhere that I can draw and get it straight, that makes my slope 0. Those, I need to curl that up a little more. Those are tangent spots, like here, 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 and here are the tangent spots, but the lines that are forming a 0 slope are what we're looking for. So in example 4, it says, for what values of x does the curve have a slope of 0? In other words, a tangent. All right, I'll pause it and I'll graph their example. Okay, so now I am looking for where I have peak or low point where I can draw a tangent line making the slope a 0. So at what numbers are those falling? Well, that would be at 10, at 14, at 16, at 20, and at 24. And I apologize, I went the wrong direction when I was drawing that graph. It actually curved downward there. And so those would be the listed answers for tangents. Section D is increasing and decreasing functions. So on page 124, you see 3 graphs, and the first one is a curvature, and they're saying that what's happening here is as my car would travel from the left, here it's climbing until it gets to the top of the hill. So this would be an increasing, and this, so a positive slope. This one would be falling downward, so it would be a negative slope or decreasing. Now what happens if I have a curvature like this? Well, overall, in general, from the left, I'm climbing up a hill. There's some dips and curves in there, but in general, I'm increasing the whole time. So this would be a positive kind of a slope, and it's going to occur when I have something that is potentially y equals x cubed. That's when you're going to get a graph like that. Then what if we have it doing something like this, where the graph was y equals negative x cubed? Well, it's basically in general falling or decreasing the entire way down. So then in example 5, and again, let me pause and draw this. All right, so the provided graph is something like this, labeling sections from A through G, and it asks, on what intervals does the function graph here appear to be decreasing? So if I'm coming from the left, this looks like I'm increasing and coming up, but from B down to C, I'm definitely curling down. So in set notation, that means I'm using B to C, and these are not zeros, so they actually have answers, so I will use the brace because B and C would be included. Now from C to D, I was off a little bit, but from C to D, that's increasing. From D to E, I'm decreasing, and again, those are not hitting the zero axis, so they are included. And then I'm climbing from E to F, but I'm falling from F to G. So the final one would be F to G for where I am decreasing.